Vanakkam, Jai Shri Krishna. Sat Shri Akal Saryan. Hey there.
मेरा नाम हृदय है.
I'm your
Just to find out what this is. At the current node in my recursive algorithm,
so hopefully I didn't miss out on any, and I believe you must have solved them up by now, so that will be easy for me and you as well to understand. Okay, so the sites are clear, right? The PDF, right?
Yes, it is.
Okay, so this is your first question, and check that which of the following regular regression model will certainly achieve zero training error on a given training data set, right? Where the error is defined as the sum of squared error. So you have been given some models in the options, and you have to find which model will definitely give you the zero training error, right? So how you define square error? This is just the predicted value minus true value square of that and sum over all the training examples. So this is how you define square error. So out of these given models, which one will give me the zero training error, right? So that we need to find out. So if you look at this thing, this square error will be zero. So if we set it to zero, this will be zero only when all the square terms will zero, right? So this must be zero for all i's. I mean, so these are the sum of the square terms. So every term must be zero, right? And this is the hxi is equal to by h. So from there you can choose that the last option is only model which will always achieve the zero error on the square error, right? And even if you can check by the option that all of these options need not to be give zero error always, right? So this is the way to solve this. So any doubt in this question?
So what is the option A?
Option is the mean of all average of all.
Okay.
Right? So you are predicting the constant to every example, every training example. Whatever the mean of the levels is, you are predicting that mean to every example. So that need not to give the zero error, right?
Yeah. Basically, the predicted one and the actual ones are same
features, and that need not to be true always. So that model need not to give zero error always. So modeling is constant, right? So let's move to the next question. Data set into a high dimension space, and in high dimension space, your data matrix is 5 of x, right? And the weight vector is given by this thing. So remember, the weight vectors can be written as a linear combination of the data points, and the data points are present in this matrix 5 of x, right? So that this vector, right? So that take for any data point x dash, and in this case, x is your zero vector. So this is your prediction alpha 1 k, and you take the current defined x dash x2, and you will find x1. So you are not given x1 here, but if you notice here, this zero vector predictions now become alpha 1 plus alpha 2 up to alpha 4. So your prediction 2. So remember the formula. This formula you have to apply in the kernel you have been given there, right? So, and the same kind of question you have in the practice given 3 plus 0.6 minus 0. Minus 0. And that is what, right? So your answer should be. So remember the formula. This formula you have to apply in the kernel you have been given there, right? So and the same kind of question you have in the practice assignment as well. So I think it should be no problem in this question. If you have any doubts in this, please ask, otherwise you can do the next part.
So alpha. So where's the alpha here?
This is alpha. Right? This is alpha, right? Remember, we call the weight vector as a linear combination of the data. The data point. And that coefficient vector is alpha. Right? So remember we call that linear combination of the data point, and that coefficient vector is alpha.
So alpha here.
This is alpha, right? This is alpha, right? Remember we call the weight vector as a linear combination of the data point, and that coefficient vector is alpha. Right? So remember we call that W to be the linear combination of data points when we don't transform our data points. So this is your alpha. Similarly, our data set is now phi of x in the transform space. So the weight vector will be the linear combination of data points. So this form is given here, right? The weight is written like this. So if you compare this, alpha vector is this vector.
Okay, this 1.3 0. Okay.
So what will be the value of alpha 1 into x test 1 test x1?
So alpha 1, this is your alpha 1, this is your alpha 2, this is your alpha 3, alpha 4, right? Now you have to find a k x test. Suppose your test to be this.
Just in case we have a value for x test value. Suppose we have some parameters values here.
Then for finding this kernel function, you must have those data points as well. Otherwise,
both x test and the x data matrix.
Sorry.
We will either have x test as the 0 vector, or we will have x test as some normal vector, and we will have the data matrix as well.
Yeah, data matrix.
Got it, sir.
And that will be part of the question itself, right, sir? In the examination, in case if it is not the 0 vector. So we will
then
the
you need access of those data points to find this kernel function.
Okay, sir. Thank you.
So I think, sir, if the data points are 0, we want to predict for always that if the x test, okay, if the x. But sir, yeah, we can move to the next question.
So in the next question, you have been given three solutions of the same linear regression problem. So W star is the analytical solution, the normal regression solution. W is the gradient descent solution, and the WS is the stochastic gradient descent solution, right? So we have applied three techniques on the same data set, and we have got three weight vectors: W star, WZ, and WSZ, right? Now this condition has been satisfied by these three vectors. So what this condition says. So this is the distance of W star and WZ, and this is the distance between W star and WSZ. So it says that WZ is most closer to W star than WSZ. So W, right? And if you look at this particular situation, let's say this is your weight vector and this is your loss function. In this case, your W star will be what? This W star, because W star always achieves the minimum error on the loss function, and this is the loss function which is achieved by the W star. So this is your W star. Now, what will be the location of W star? It says this is the distance of W star and WZ, and this is the distance between W star and WSZ. So it says that WZ is most closer to W star than WSZ. So W, right? And if you look at this particular situation, let's say this is, so it says that WZ is most closer to W star than WSZ. So W, right? And if you look at this particular situation, let's say this is your weight vector and this is your loss function. In this case, your W star will be what? This W star, because W star always achieves the minimum error on the loss function, and this is the loss function which is achieved by the W star. So this is your W star. Now, what will be the location of WZ and WSZ? Let's say WZ is somewhere here. Let's say your WZ is somewhere here, right? And so this will be loss that will be achieved by WZ. And what will be the position of WSZ in this case? Remember these conditions now. So this condition says that WSZ is far away from WZ to W star, right? So WSZ should be far than WZ from the W star. So rather it should be somewhere here, or and even if you look at here, it must be distance from W star should be higher than this distance, right? So doesn't matter where it's lying. The loss function for WSZ will be always more than WZ, because the loss function for WZ will be somewhere here, and for WSZ will be somewhere here. So WSZ will always achieve more error than the WZ, right?
So can you come again to the equation that is given in the question itself?
Yeah. So this is the distance of WZ from the W star, right?
And
this is the distance of W star from WSZ.
Okay, got it. Now I got it. Okay, yeah.
So the question saying that the WZ achieves the error 0.5. So which of the following approach is more likely to give less training error, right? So out of these two, which will give me the less error? The one which is closer to W star, right?
Yeah.
Gradient descent will give me the less error.
Okay. And so if it is opposite, then it is the stochastic gradient W.
Yeah, if the stochastic gradient descent weight vectors is closer to W star, then that will achieve less error.
Less error. Okay.
So I have a quick question. We say gradient descent will have less errors in this case, because we already have given the condition that the distance for the weight vector is lesser for gradient descent as compared to the stochastic.
Yes.
But in case if we have not been given this,
then it depends what vector you got using this solution. So it may be the case that you have used different iterations in gradient descent, and you have and used different number of iterations in stochastic gradient descent. Then those weight vector can be we cannot comment that WG will always be closer to W star than WS. So it depends upon the what parameters you have chosen, like random gradient. I think that will depend. But here it's given that WG is closer to W star, right?
Yeah. So it is only true for this condition. Yeah.
Yes.
Okay.
So let's move to the next question. So here you've been given one dimensional data set. Here you have been given three data points x1, x2, and x3, and only one features. Right. So the label are 1, -1, and 1. Now you have to fit the model. So first question is you have to fit the constant model. Okay. So how you will do this question?
So
X transpose X. I mean, that is the standard way of doing it.
Okay, so and what will be x in this case?
It's a row vector.
Row vector. What is that vector?
It's -102.
But we are fitting constant here, right? We are fitting like let's call it W0. So we are fitting the model of form x y equal to W0. We are fitting a constant.
Equals to mx plus c.
Okay,
And what is the difference in these two models? Let's say W1 x1 and W0 W. So this is your one model, this is another model, right? Here we are fitting constant. Here we are dependent on the features as well, right? So what will be x in this case, and what will be x in this case, and what will be x in this case? Let's say W0 plus W1 x1.
In the above one,
First
insert set is x is 0, I think.
X is 0. You mean 0 vector. Okay, and in this case?
-102.
In this case, this. Okay, and what in this case? What about
Constant plus 0.
It is same.
Same vector, -102.
so when do we add dummy feature in the data set?
When we have that intercept.
Intercept. So in this model we have intercept, right?
Yes.
So in this x we will have, okay, now come to this part. What will be the x in this case?
That's
Zero.
a vector. So yeah.
It's a dummy feature only, right? You can think as a dummy feature x0, which is taking value 1 always. Right? So in this case, x will be 1, 1, 1. Right? Just think it as a dummy feature which is taking value as 1.
So I'm still not able to get it.
Sir, can you please just draw a diagram for this thing? I mean, this equation. Can do that.
Okay, so let me.
So I have a quick question.
Hmm.
My understanding with this was if y1 is equal to b0, so in this given data points, if I'm trying to fit, so I will take y1 as simply the values of y, because we are just having the constant. So the weights will be just 1 minus 1, 1. And then we'll take an average of those three.
Yeah, that is correct. Yeah, that is correct. So that is another way of solving this. Since we are fitting the constant here, right? So what is the square loss? The square loss is this, the predicted values minus the actual values, right? So prediction is always a constant. And if you solve this loss function to minimize this loss function, you have to take the derivative with respect to the beta 0, and that's all. That means that derivative will be twice of beta 0 minus y i's, right, for all i's. And if you solve for beta 0, it will be the sum of all y i's and divided by n, right? So this is what you are doing. So whenever you are fitting a constant, remember that that constant is average, and it's intuitive as well, right? Someone says that give me a constant that best describes your labels. What will be that that constant? It's just a mean of those labels, right? So actually you need not to do any calculation in this question. So you just take the average of labels and just report that mean, right? But if someone solves in this manner, right, where you choose x transpose inverse xy, then you have to take care that what x you are choosing. This approach is clear, right? Why we are choosing mean if we are fitting constant?
I'm not clear. Would you kindly clarify on this? Like, we are assuming y is equal to y1 is equal to beta 0. That means I'm accepting that it's a constant.
Yeah, it's a constant, right? It's beta 0 is a constant. Or you can think as a W0, or what notices we have followed in the lectures. The predictions for any data point, whether it's a training data point, you just look at those labels and average it on any data point, and the true value is that.
But for this function, right? So you have written here. So L, it will give some number to me, but it doesn't give me any average. So why you taken the average over here, sir?
No, so this is my loss function, right? This is my loss function.
Yes,
Your
right.
Okay.
Okay. Now come to this particular approach where if you try to solve this x transpose, then you have to take care what x you are choosing.
Okay, one question here. Okay, that beta naught is going to be the average of each of them, because
yeah.
I think I got this way. What I mean to say, just keep the beta naught, okay, like that only. And instead of yi, just keep putting the yi value. Okay, so we have 3 points over here, right? We do the summation. Beta naught minus first y point. Okay.
Okay.
Plus again beta naught minus second y point.
Okay.
Plus beta naught third y point, right? Equal to 0. Because we are seeing that this thing. So it will have 3 beta naught, right?
So you have beta naught minus 1 square, right?
Yes.
Now you have to.
Yes, sir.
So this will be beta naught to be.
Please.
So, sir, you have taken here actually instead of average. I mean, what I'm saying, you have taken the derivative of against the beta naught, right? Then you set it to 0. Even that also will give the minimum value, right? Where exactly the value will be minimum, isn't it?
Yes.
So we find the gradient, right? The global minima. That's what we say. So using that thing for this function, you taken the derivative against the beta naught and set it to 0. With that thing, you found the value of beta naught where the value will be minimum.
Minimum, right?
Let's justify the thing, sir. Thank you, sir.
So that's what.
Like you have written these 3 equations, sir. So you are writing the value of x vector, right?
So in the first case you wrote that it is 1, 1, 1. Then what will be in second case and third case? Like in the first case you wrote that it will be 1, 1, 1. That constant.
Yeah, we are coming to that. We are coming to that.
Okay.
So when you do this summation, beta naught minus yi whole square. If we take the differentiation and put it to 0, this summation, then it will become something like 2 and summation beta naught minus beta yi. And so if we equate it to 0, then the beta naught is equals to y1.
No. So this is summation, right? This is summation. If the differentiation will be 2 beta naught minus yi. This is your differentiation. If you set to 0, it means what? This is your 2 and beta naught, right? Minus summation over yi's.
Okay.
So this is beta naught will become. So 2 will be here also. So that goes to 0. Doesn't matter. So this will become summation over yi's by n, right? This is your mean.
Okay. Got it. Okay. Yeah, thank you.
Okay. If you follow this path, which is actually I won't prefer, because in the constant, whenever you're modeling a constant in a regression model, then it's just a mean of labels, right? It makes sense as well. So in this case, what x you will choose? Let's say I'm fitting model y equal to w0, I'm fitting w, and again I'm fitting model w, right? So let's talk models. Now in this case, what x you will choose? In this, let's think about this first. So in this case, x is pretty easy, right? It's whatever is given, -1, -102, right? Now, what about in this case? You just think it's like x0, where x0 is always 1, right? So you have added dummy feature. In this case, x will become your -1, 0, 2, and this dummy features you will add. So this will be your data matrix in this case, right? Because you have added a dummy feature. And you are learning intercept as well, right? What about this case now? You can think is this as a w0 x0. Where x0 is a dummy feature, which all ones, right? So what is your x in this case? This is all dummy features only, because you are not adding your feature x1 here in this model, right? So x will be 1, 1, 1. So in this particular model, whatever x you are choosing is a constant only, and that vector of ones only, right? And what about this model? What will be x in this case? Okay, so this corresponding to w0, this corresponding to w1. That you need to take care of, right?
I'm not really clear about why we are choosing 1, 1, 1. -102, it is coming from the data that is given.
This is the corresponding to x1, right?
So I also have the same question as Ravi.
We are taking 1, 1, 1 because we're taking dummy features, I guess.
Dummy feature, right? Yeah. So or if I draw it in the vector form, so this will become something like that. So the weight vector, so y equal to w0 plus w1 x. So x1 is like your or say w0 x0 plus w1 x1, where x0 is always 1, right? And if I can write it as w transpose x vector, right? W transpose x. So in this w is your w0, w1, and x will become your this x0 and x1. So this x0 should be this. So this x0 will be 1, 1, 1.
X0 act like a unit vector.
X0 is the dummy feature that we call it. Right? And x1 is given to like -1, 0, 2. And similarly, if you are modeling only w0, in this case, you are only modeling w0, x0. You are not adding your first feature at all. So in this case, x, so you can write it w transpose x, where w vector will be your this w0 only, and x will become the dummy features only, 1, 1, 1.
Excuse me, sir.
Sorry?
Sir, actually, when live sessions happen, in case of single variable, that is one-dimensional data, we can use the formula for W as summation of xi yi by summation of xi square also, right? We will straight away get the value for W. Do we really need to compute this much?
Yeah.
Actually, it's easy if we calculate using this formula, summation of xi yi by summation of xi square.
So don't talk about that one, but this all we have already done in that, so that's what I'm doing here, right?
Okay, sir. No, I'm just talking about time consumption. So in case of single variable, you can use that formula.
This question is just average, right? This is in this particular, if you are fitting a constant model, that is always gonna be an average of labels. Actually, you need not to spend much time on this question at all.
Okay.
But if someone goes into this approach that I'm mentioning, you have to take care of this x.
Yes, sir. No, what I'm asking is we can use that formula as well, right? Summation of xi yi by summation of xi square. Okay, sir. Thank you.
Okay. So what about this part? Okay. So we have already discussed this. This is kind of form y equal to w0 x 0. So in this case, you will choose x as that is -1 to 0 or 2, right? And y is already given to you, and you can apply x transpose xy. Right? What about this model? If I talk about this model, y equal to w0 plus w1 x1, and I'm taking also square of the feature. Now, what do you think x will be? Now you have 3 weight vectors you are learning: w0, w1,
111, -102, and 104.
Right. So this will be 111, and corresponding to x1, this will be -102, and corresponding to x square, this is gonna be your x square now. So 104.
So it's something like what we were taught in machine learning foundations. Practically the same thing.
Yes.
Okay.
Right. So this is like w transpose or x, and this x becomes now.
Hello.
Yes.
So I think the answer to the previous one is 0.33, right? It's the average of y. That's
0.33.
Okay. But that doesn't really. But if we had to, let's say, just for the sake of argument, if you had to find an equation which is y is equal to beta 0 plus beta 1x, let's say with the intercept, then you have to do the long process. You have to take the inverse and compute.
Yeah, you can go that way.
Okay. But is there an algebraic way of doing it is what I'm wondering. I mean, here we have, like, it's very clear. Sorry, if you go back to the equation, like beta 0 minus y, right? So this is minimum when beta is actually the mean of y, right? I mean, you can differentiate and you get that also, right?
Yeah.
That's clear. By logic, we can answer this. But is there an algebraic way of doing it?
For w0 plus w1 x1, you are
no, not that one. That one I know the method. I mean, it was taught in MLF also. Like just here, like beta 0 minus y1, just this method, is there an algebraic way of solving it?
What do you mean by algebraic? This is what we have done, right? We set to we take the derivative and set to
yeah,
0.
okay, that's the only. Got it.
If you find loss function, take the derivative with respect to w0, w1. That's how we arrive this formula, right? That's how we arrived on this formula. You can go that manner for as well, but that will take time because you have to take derivative with respect to w0, with respect to w1, and then you have to find the formula that someone has mentioned summation over xi by I is the summation xi is here. So that all formulas come from that taking derivative and set to 0 by using that, right? So that's how we can get this formula, right? Remember, we find loss function as summation over the prediction value, right? So w transpose xi minus yi and square. Take the derivative with respect to every w, and then we get this. So same thing we are doing, but in terms of concept, it makes more sense to just apply. Just remember that the mean will be the model.
Sir, I think someone what he said about summation of xy by summation of x square. That is what he said about summation.
For the model.
Sir, I think.
Would be the best fit for the model.
Sir, I think someone what he said about
for the model.
sir, I think someone what he said about sir,
For the model.
Sir, I think someone.
Be the best fit for the for the model.
Sir, I think someone what he said about summation of xy by summation of x square. That is well for when that w0 is not there, so it is y equal to w1 x1.
Yeah, for that model, y equal to the.
For that model, that is absolutely
Yeah.
very quick method to find out.
So it's again the same algebraic way. You find the loss function.
And that's what she was trying to say. We can
take
use
the
that
derivative. Yeah, again, same thing. Same path, same cheese, but using different path, right? How you go to from one point to another.
Yeah. Let us move to next question. Yeah. This.
Okay, so in this case, you have to find W is upon WMLE, right? And you've been given X as well and Y as well, and lambda penalty is given to you 50. Okay, so what is W is?
Lambda into weight square.
It's a
will
loss
come.
function square plus lambda into w the whole square, right?
That
That's
is
what we
loss.
write.
What is loss? That is loss, right?
W is what we write. This is how we write,
W
right?
is means that regression value
Yeah.
will be there, and then lambda into weight square will be there.
Yes, we add that regular parameter, right?
Yes, yes.
Whatever you are saying is a loss function. Here I am asking what is the weight that you get. In
Okay, okay,
MLE, what
yeah.
you get?
Yes, yes, yes.
MLE, it's like yeah, that same thing only, right? Like axis transpose, or I mean inverse than xy.
Correct.
Yeah, and what is W is?
Same formula. So I think it will be 1.
No, XX transpose plus lambda I, the whole inverse.
Yeah, this one. X transpose lambda I inverse xy. This is W is.
Okay.
And this is WMLE. Right? And if you notice the data WM inverse
xy.
Correct.
Yeah, and what is W is?
XX transpose plus lambda
xy. This is W is.
Okay.
And this is WMLE. Right? And if you notice the data set, if you find X in this will be transposed.
So, sir, what I had told, that is the loss function for W ridge, right?
Yeah.
Everything messed up, sir, now.
W square. That is a loss function.
Everything messed up, sir, now. Thank you.
Yeah, this is WMLE. Right? And if you notice the data set, if you find X in this will be transposed.
So, sir, what I had told, that is the loss function for W ridge, right?
Yeah, that you mentioned plus lambda norm of W square. That is a loss function.
Everything messed up, sir, now. Thank you.
Okay. So if you notice X into Y will be constant, right? X into Y will be constant.
Yeah.
Right? So can I cancel those?
Yeah.
This is constant, again this will be constant. If you look at X transpose,
Yeah, it will be same. Yeah.
it's a constant again, and if you find X transpose gonna be 50. So in this case, even calculation of X, Y, and everything, it's just X transpose gonna be 50, and lambda is given to be 50, right? And inverse will be 1 by 100, right? 50 plus 50. Similarly, X transpose is 50, so it's just 1 by 2.
So we do not need to find the inverse also, I think.
No, this is just a scalar, so inverse will be 1 by 2. Okay.
We do not need.
So it's just 1 by will be 1 by 100, right? 50 plus 50. Similarly, X transpose. Transpose is 50, so it's just 1 by 2.
So we do not need to find the inverse also, I think.
No, this is just a scalar, so inverse will be 1 by 2 of that, right? Because X transpose this is 50 plus 50, right? So inverse of that will be what? It's just 1 by 1 by 100, right? And this is 50, I think.
Say that xy got cancelled out. That part is clear. Yeah, that part is clear that xy got cancelled out because it's then after how we are simplifying it, like xx transpose plus lambda I, we are putting it simply 50, and then the bottom part we are putting.
What is X transpose? What is X transpose in this case?
We will simply multiply 9 plus 25, 30 for 50. Yeah, it is 50.
50, right? So what is lambda? 50. I
Lambda
will be
is also
the
50.
one. I is just a constant here in this, right? So I is the identity matrix of shape D plus D. So this is constant. So this is 100, right? X transpose plus lambda. It's 100. So inverse of that will be 1 by 100.
Okay. Okay.
Sometimes more information lead us to confusion. That way, if in this question y value will not be there, then we can easily solve this question.
Even if you have been given by here, you just if you do the calculation, it won't affect, right? It's just
Yeah.
extra calculation you are doing.
And sir, one more thing, sir. If it is the W hat lasso or L1.
Lasso, we don't have a solution, right? This W
Solution,
solution.
right?
For
Yeah.
Okay, okay, got it, yeah.
It doesn't have a closed form solution for Lasso.
Okay, got it, yeah.
Okay, again in this case, you have to fit the model of case W0 plus W1x, right? So again, one-dimensional data points, and these are corresponding labels. In this, you are using the validation, so cross-validation techniques, and validation set is x2 by 2. So you are training model on these two models, these 2 points. So this is your x1, this is your x2, this is your x3. So you are validating over x2 by 2. So you are training your model on x1 and x3, right? You set it for validation, and this is your training set now. So you are training your model on 0, 0, 2 and 3, 1, right? So these are your labels and these are your data points. So what will be the best fit? And these are corresponding labels W0.
All this question.
Or L1.
Lasso, we don't have a that solution, right? This W. Okay, again in this case, you have to fit the form solution for. For Lasso.
Okay, got. Got it, yeah.
Okay, again in this case, you have to fit the model of case W0 plus W1x, right? So again, one-dimensional data points, and these are corresponding labels. In this, you are using the validation. So cross validation techniques and validation set is x2 by 2. So you are training model, right? These are your.
That's the way we can find, right?
These 2 points.
1 minus 2, 0, 0, 0.3.
Yeah, and what is constant?
2.
Intercept.
In that.
1 will be somewhere. And the line, and it will be W1 will be minus 1 by 3. And
okay. The
this will be 1 minus 3x minus 0, right? So y equal to minus 1.
Okay.
Sir, can we get this rights?
Can we get this what?
This document and yesterday's document.
Yeah. I'll add to the same folder.
Okay, sir. Thanks.
Okay, so classification problem. where the class levels are 0, 1, 2, and each state means that teachers taking value algorithm.
Two.
One.
Two.
One.
parameters.
Why is taking
Two parameter.
Right?
Yeah.
Because 3 classes classification problem.
Yes.
Right?
okay? Three
Now-
class. Okay,
now
sorry, it
find-
is 3 class. Right?
Now in the conditional space, so in the conditional space you have y given y equal to 0, given y equal to 1, and given y equal to 2, right? For all three you have to calculate. So you have to calculate for f1, f2, and f3, right?
Which question are you looking at, sir?
I'm not remember the question number in the portal, but this
Question
is
number
this-
8. Question number 8 of
Question 16.
Okay.
So question is mentioned here, right? So you have been given 3 class classification problem, and the features are binary features, 3 features. So all these you have to calculate. So
So it is
estimate
question number
here.
16 in portal. Question number 16 in portal.
Yeah, got it.
So all these 3, 6, 9 parameter here, 2 parameter here.
We have f1, f2, f3. Okay, f1 will take 0 value or 1 value, right?
1 value.
So-
Yeah, but
so as per-
I just need one estimate, right?
Yeah.
Because if I calculate probability of f1 given
Y given
y equal to 2. So
Okay.
this
If we calculate
all,
2 of them, then the third one is automatically calculated
Okay,
because
okay,
the total
okay.
sum is 1.
Oh, got it. Yeah.
right? So
Sir,
For
sir,
go on, Vasu.
sorry, just 1 second. Sir, in this case, when they just mention knife base, we assume that it's your conditional like holds, conditional independence holds.
knife means that conditional
Independence holds.
independence.
Yeah, correct.
The knife
Sorry.
birds itself mean that.
Yeah. Ravi, go ahead. Sorry.
Okay, so for y is equal to 0, we have f1 given y is equal to 0, f2 given y is equal to 0, f3 given y is equal to 0. So how many factors are there in that? 3? Or
Three
what?
parameters. So for this distribution, right? So you need to estimate 1 minus. Similarly for f2 as well. So f2 have so 3 for this and the
2 raised to the power d.
Huh?
This is formula now.
Yes, he was saying that 2 plus 1 formula to be used. Yes.
In this question, if the conditional independence is not assumed,
Let's say
Answer will be 23.
in the distribution of x given y equal to 0, right?
7,
So you can find
21. 20. Answer will be 23.
so you have d features. Okay,
2
d
power
is
d
3 in
minus
this
1.
equal to 2, 7 here, and this will be how many?
21 plus 2, 23.
23, right? So 23 parameters we have to estimate in that. If you drop the knife condition.
Sir, please repeat the same. Yes, sir. This condition.
Which condition? Can you please mute? I think I. So in this labels, you have two estimation, right? So now in this conditional space, x. So this
Assumption is equal to 1 and y is
yeah for this, so 21 and
why
2 for
7?
the
I'm so sorry, I don't understand why 1 less.
because in this distribution you have 8 points, right? Once you have found the probability for the 7 point, the 8 one gonna be 1 minus some over all.
So if it is 3 levels in features, then it becomes 3 power d.
3 features in that, yeah. Then it will become 3 into 3 into 3, right? 3 raised to power 3.
Okay.
So
3 raised to power 3 minus 1, right?
minus 1. The parameter will be 3 raised to power d minus 1 parameter. And then you have to multiply it with the classes as well, right? How many classes? Y equal to 0, y equal to 1.
Of y, they are minus 1 more parameters, right?
Yes.
Each feature.
If you assume the knife one is
6.
right, so this is for y equal to 0. Similarly, for f2, you have to calculate f2 is and
20. 6 for y is equal to 1 and 6 for 0, 1, 2. You
Okay, so in this particular question, you have been given the data matrix X of the shape D cross N. So, so every column is a data point. So this is your first data point, this is second data point, third data point, fourth data point, and the corresponding levels are 1, 0, 1, 0. Right now, you have been given that this is the general notation, right? That we have discussed yesterday as well. So now it's asking what is the value of P30. So what does this mean?
P30 means, sir, 0 is the level and 3 is the third one.
Yes, so this is the estimate for P that.
So hello everyone. हम यहाँ पे मीन ले रहा है +1 का होल क्यूब। हाँ तो 1 1 1 सब में आएगा क्योंकि +1 एक्स्ट्रा आ रहा है तो 4, ठीक है, ये ट्रांसपोज है, ठीक है। तो इसको -3 इंटू -3 5 इंटू 5 4 इंटू 4 उस सब का सम हुआ 50, ठीक है। और हमें निकालना क्या है, एक्स ट्रांसपोज एक्स प्लस लैम्डा है। लैम्डा हमको 50 गिवन है, ठीक है। 50 में 50 जोड़ दिए लग रहा है इक्वेशन ऑफ जाएगा और ये नीचे चला आएगा, ठीक है। 50 ऊपर नीचे 100 नीचे, इसका x2/2, ठीक है, x2/2। तो जो हमारा जो हाँ y1 होगा, ये x1 होगा। तो हमारे पास 2 डाटा पॉइंट है ना, 0 2 और 3 1, इनमें से कोई भी से 200 डाटा पॉइंट लेफ्ट चाइल्ड में चला गया। क्लास 1 जो वैल्यू रिप्रेजेंट करेगा उसका काउंट है 50, ठीक है। तो मैंने वही किया, इधर 200 गया, 200 में से 50 का वैल्यू जो आएगा वो 1 आएगा, मैंने लिख दिया। तो बाकी को बचा 150 कर रहा है। तो और एक बात ये बोल दिया है कि क्लास 1 इस 3 वैल्यू मतलब हमारा ट्री केवल 50 है। है और फॉल्स वाला कितना है, तो फॉल्स इसको 0 मिल गया तो लेफ्ट चल 500 में से चल, ठीक है। तो एंट्रोपी है यहाँ। तो ट्रू वाला कितना था, ट्रू वाला पहले कोई भी लिख सकते हो, कोई दिक्कत नहीं। ट्रू वाला कितना था, 300/500। है ना, इंटू फॉर्मूला जो होता है 300/500 इंटू लॉग 300 लॉग ऑफ 200/500, बस वही मैं करके 0.196 आंसर। ये देखना है, इतना छोटा सा ट्री, ऊपर वाला बाकी सब भूल जाना। तो 50/200 हमें फाइंड करना है 0.81, ठीक है। कैलकुलेशन पार्ट हम नहीं कर रहे हैं। सिमिलरली राइट के लिए जब हमें 5.300 है, उसमें से ट्रू वाला 250 है, फॉल्स वाला 50 है, तो हमारा क्या बनेगा फॉर्मूला यहाँ पर 250/3 वाला कितना था 50/300 log ऑफ 50/300, इसको सॉल्व किया 0.65 आंसर आएगा। अब हमको लास्ट में बोल रहा है कि क्या आईजी फाइंड करना है, मतलब सॉरी कहाँ गया, हाँ इन्फॉर्मेशन गेन फाइंड करना है। इन्फॉर्मेशन गेन का फॉर्मूला होता है एंट्रोपी ऑफ पेरेंट, जो कि हम ऊपर निकाल चुके हैं, माइनस ऑफ, आप बिग ब्रैकेट लगा दीजिए, गामा, गामा बता रहे क्या है, एंट्रोपी ऑफ राइट प्लस एंट्रोपी ऑफ लेफ्ट, ठीक है। मतलब जो पेरेंट का एंट्रोपी है उसमें से राइट और लेफ्ट का माइनस करना है, और एक गामा और 1 माइनस गामा पेरेंट का एंट्रोपी मल्टीप्लाई करना है। गामा क्या होता है, सक्सेस, मतलब टोटल में से सक्सेस कितना हुआ। जब पेरेंट का देखें, पेरेंट हमारे पास 500 था, उसमें से ट्रू कितने ने बोला, 300 ने ट्रू बोला, तो गामा का वैल्यू होगा 300/500, ठीक है। कितनों ने, मतलब गामा गामा बेसिकली होता है डी एस अपॉन टोटल, ठीक है। तो यस कितने ने बोला है, डिसीजन कितने ने, यस 3/5 हो जाएगा, 3/5, ठीक है। तो 1 माइनस गामा क्या हो जाएगा, को लिख देना है गामा, और इसको कैलकुलेशन करेंगे तो 0.96 हमने पेरेंट का निकाला था एंट्रोपी, और 0.81 0.65 चाइल्ड का निकाला था, और इसको मल्टीप्लाई किससे करना है, जीरो, ये ट्रू वाला है ना, ये ट्रू वाला है, मतलब राइट वाला ट्रू है, तो इसमें 3/5 से मल्टीप्लाई करेंगे, और इसमें 2/5 से, इसको सॉल्व किया 0.255 आंसर, ठीक है। ओके नेक्स्ट पीडीएफ, इसको जूम करते हैं, वेट कि कंडीशन को पूछ, हमको यस 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 फाइंड करना है तीनों का, x1 का भी यस, x2 का भी यस, और x3 देखिए एक लेंथ है हमारा 4, सौ डाटा पॉइंट है, तो 50 पॉइंट यस वाले में चले गए, ठीक है, और 50 बिलोंग टू +1, और के एन एन क्लास 1 यूज प्रेडिक्टेड लेवल ट्रेनिंग डाटा सेट, ए पॉइंट कंसीडर एट, ओके। जब हम के एन एन यूज करते हैं तो नाइबर यूज करते हैं, ठीक है, ये पॉइंट है, बहुत सारा इसका नाइबर, तो ये पॉइंट क्या चला कि ये खुद को ही नाइबर ले लिया, ठीक है। देखो ये जो पॉइंट है, इसका जो नाइबर है जी, ये बात जो बोलेगा वही मानेगा, ठीक है, ऐसा है। तो अगर ये बोलेगा +1 तो ये +1 अपना वैल्यू लेगा, ये बोलेगा -1 अपना -1 वैल्यू लेगा, ठीक है। लेकिन ये चालाक प्राणी ने क्या किया, ये अपने आप को ही नेबर मान लिया, ठीक है। तो ये क्या हो गया कि इसका जो खुद का वैल्यू होगा, खुद से ही पूछेगा कि हमारा वैल्यू क्या है, +1, हाँ, तो ये खुद को +1 मान लिया। तो ऐसे सिचुएशन में कभी भी इसके पास एरर आएगा। लेट्स सपोज इनिशियली इसका वैल्यू -1 था, ठीक है, और इसका पड़ोसी बोला कि नहीं मेरा +1 है, तो ये पड़ोसी की बात माना, तो ये अपने आप को +1 किया, तो ऑब्वियस बात है यहाँ पे एक एरर आया ना, मतलब एरर जो, मतलब मिसमैच हुआ ना, ये प्लस अपने आप को -1 माना था, ये +1 माना, और अल्टीमेटली रिजल्ट आया +1। लेकिन ये क्या किया, अगर इसने अपने आप को ही नेबर मान लिया, ये खुद को ही -1 माना, और खुद से पूछा कि हमारा वैल्यू क्या है, तो खुद ने बोला कि -1, तो खुद को ही बोला कि चलो मेरा भी फाइनल वैल्यू -1। ऐसे सिचुएशन में कभी भी एरर आएगा, मतलब मिसमैच होगा, नहीं होगा ना, जीरो मिसमैच होगा, तो ये थोड़ा इजी है। इसमें क्या करना है, पूछा है लेवल्स दिया हुआ है, तो पूछ रहा है कौन कौन में किसमें जीरो मिसमैचिंग होगा, मतलब इस क्लासिफिकेशन। तो आप क्या कीजिए, x1 यहाँ दिया हुआ है ना, x1 को डॉट कीजिए, w क्या आएगा 1 0 इंटू 1 2, तो 1 से मल्टीप्लाई होगा, 0 2 से मल्टीप्लाई होगा, तो इसका वैल्यू आ जाएगा 1, ठीक है। ये पॉजिटिव है और गिवन भी पॉजिटिव है, सिमिलरली इसके साथ भी करेंगे तो पॉजिटिव आएगा, इसके साथ भी मल्टीप्लाई करेंगे तो नेगेटिव आएगा। मतलब चारों में मिसमैच, मतलब एरर यहाँ से आएगा 0, इसमें भी और इसमें भी। लेट्स सपोज इसका लेते हैं तो 1 0 है हमारा क्लास x1 और इसको मल्टीप्लाई करते हैं -1 और माइनस, दैट इज इक्वल टू -1, 0 मल्टीप्लाई होगा -4 से, दैट इज इक्वल टू 0, दैट इज इक्वल टू -1। पूछ रहा है कितना पैरामीटर लगेगा नेव बेस क्लासिफिकेशन। नेव बेस मतलब क्या होता है? नेव बेस होता है एक्सेप्टिंग द कंडीशनल इंडिपेंडेंस, ठीक है। इसका फॉर्मूला होता है n-1 इनटू डीके, बीके नहीं डीके, और प्लस k-1, ठीक है। अब हमको ये सब वेरिएबल चाहिए ना। के हमारा होता है क्लास, के इक्वल टू क्लास, हमारा क्लास कितना है? कभी कभी गिवन होगा, देखिए 3 क्लास गिवन है ना, तो के का वैल्यू हमारा 3 आ गया। अब डी होता है हमारा डायमेंशन ऑफ द फीचर। डायमेंशन ऑफ द फीचर कितना? f1 f2 f3, 3D में है तो हमारा डी का वैल्यू आ गया 3, डी का वैल्यू 3। अब हमको n चाहिए। n वो होता है कि वो जो फीचर जो हुआ, फीचर का कितना वैल्यू हो सकता है। फीचर का वैल्यू या तो दो ही हो सकता है, देखिए इस टाइप से बनेगा f1 f2 f3। अब ये f1 का क्या क्या वैल्यू हो सकता है, या तो 0 या फिर 1, तो बस वही हो गया, ये हमारा हो गया n। n कितना होगा? 2, n हमारा हो गया 2। ये सारा चीज फॉर्मूला पुट कीजिए, आंसर है 11। ये तो हो गया एक्सेप्टिंग द एंड वो होता है सब होगा, देखिए 3 क्लास गिवन है ना, तो के का वैल्यू हमारा 3 आ गया। अब डी होता है हमारा डायमेंशन ऑफ द फीचर। डायमेंशन ऑफ द फीचर कितना? f1 f2 f3, 3D में है तो हमारा डी का वैल्यू आ गया 3, डी का वैल्यू 3। अब हमको n चाहिए। एंड वो होता है कि वो जो फीचर जो हुआ, फीचर का कितना वैल्यू हो सकता है। फीचर का वैल्यू या तो दो ही हो सकता है, देखिए इस टाइप से बनेगा f1 f2 f3। अब ये f1 का क्या क्या वैल्यू हो सकता है, या तो 0 या फिर 1, तो बस वही हो गया, ये हमारा हो गया n। n कितना होगा? 2, n हमारा हो गया 2। ये सारा चीज फॉर्मूला पुट कीजिए, आंसर है 11, ठीक। ये तो हो गया एक्सेप्टिंग द इंडिपेंडेंस। अब एक और केस होता है IGNORING, इग्नोरिंग द इंडिपेंडेंस। इसका फॉर्मूला होता है n की पावर d -1 k प्लस k-1, ठीक है। वही चीज n हमारा वही रहेगा, कितना वैल्यू हो सकता है फीचर का, d मतलब डायमेंशन ऑफ द फीचर, k हमारा नंबर ऑफ क्लास, ठीक है। और ये बात ध्यान रखना, नेव बेस क्लासिफिकेशन होता है एक्सेप्टिंग द इंडिपेंडेंस। अब हमारा k प्लस k, अब एक और हो गया। अब ये f1 का क्या क्या वैल्यू हो सकता है, या तो 0 या फिर 1, तो बस वही हो गया, ये हमारा हो गया n। n कितना होगा? 2, n हमारा हो गया 2। ये सारा चीज फॉर्मूला पुट कीजिए, आंसर है 11, ठीक है। ये तो हो गया एक्सेप्टिंग द इंडिपेंडेंस। अब एक और केस होता है IGNORING, इग्नोरिंग द इंडिपेंडेंस। इसका फॉर्मूला होता है n की पावर d -1 k प्लस k-1, ठीक है। वही चीज n हमारा वही रहेगा, कितना वैल्यू हो सकता है फीचर का, d का d मतलब डायमेंशन ऑफ द फीचर, k हमारा नंबर ऑफ क्लास, ठीक है। और ये बात ध्यान रखना, नेव बेस क्लासिफिकेशन होता है एक्सेप्टिंग द इंडिपेंडेंस। अब हमारा नेक्स्ट क्वेश्चन है कि हमारा डाटा पॉइंट दिया हुआ है, उसका लेवल दे रखा हुआ है, इसका लेवल ऊपर में ही लिख दो, लेवल सो के निकलेंगे, ठीक है। तो ये इसका वैल्यू 1 है, मतलब प्रेडिक्शन 1 है, इसका 0 है, इसका 1 है और इसका 0 है, ठीक। यहाँ पे अब हमारा नेक्स्ट क्वेश्चन है कि हमारा डाटा पॉइंट दिया हुआ है, उसका लेवल दे रखा हुआ है, इसका लेवल ऊपर में ही लिख दो, लेवल सो के निकलेंगे, ठीक है। तो ये इसका वैल्यू 1 है, मतलब प्रेडिक्शन 1 है, इसका 0 है, इसका 1 है और इसका 0 है, ठीक। यहाँ पे गिवन है, ठीक है। अब हमको ये बोल रहा है कि पूछ रहा है कि प्रेडिक्स इसका वैल्यू फाइंड करके, इस ये जो नोटेशन लिखा हुआ है इसका मतलब ये है कि प्रोबेबिलिटी ऑफ, नीचे 3 है मतलब f3 इज इक्वल टू 1, ये p मतलब सक्सेस है, ठीक है। यहाँ देखिए ये बीच वाला f2, ऊपर वाला f1, फिर 3 का वैल्यू 0 है, लेकिन यहाँ ऑफ 1 0। y इक्वल टू 0 कितना है, सेकंड और फोर्थ वाला, तो सेकंड और फोर्थ वाला है केवल हम देखेंगे, मतलब यस हाँ, y इक्वल टू 1 लेकर सॉल्व करते हैं तो क्या होगा? वही चीज़ यहाँ पे y इक्वल टू 0 सिमिलरली तो 2/2 दैट इज 1 और फीचर 3 0 होना चाहिए। कैन नॉट प्रेडिक्ट दीस थिंग्स, ठीक है, इनसफिशिएंट आंसर हो जाएगा। और यहाँ पे पूछ रहा है अगर आप क्या बोलते हैं जॉइंट प्रोबेबिलिटी दिया हुआ हो तो कंडीशनल निकालोगे, ऐसे निकालेंगे कंडीशनल इक्वल टू जॉइंट अपन मार्जिनल होता है, जॉइंट हमको दिया हुआ है, जॉइंट मींस p of x, y। और इस वाले को भी सेव कर लेते हैं।